Welcome to the Digital Amateur Television Experimenters Night. This is VK7OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. Do you realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world? Also participate in the night by coming up to the Queen's Domain clubrooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And I've got Richard VK7ZBX in
G'day,
the
Justin.
studio. How you going?
I am very well.
How's your week been?
Fantastic. Fantastic. No, we had a really good Easter.
Oh, okay.
Didn't quite do as much as I wanted to, but I got some radio things done.
And we'll hear about them in a sec. So,
Don't tell the wife. Shh.
yeah, shh.
I was busy.
Busy. Yeah. So, before I commence, I would like to acknowledge Tasmanian Aboriginal people as the traditional owners of the land and pay my respects to elders past, present and emerging, for they hold the memories, the knowledge and the culture and hopes of Aboriginal Tasmania. Now, the reason why I've got Richard in the studio is Richard brought in a very nice little kit that he had put together. So
Yes.
tell us all about it, Richard.
Look, those that have got 9700s,
Which of many?
which are quite a few, look, they're a fantastic radio. Look, one of the limitations that ICOM seem to have is they only have multi-band radios. They have one push-to-talk out. Now, they win some brownie points by having it as a dual function. It's either a push-to-talk in or a push-to-talk out.
Okay.
Which is sort of pretty handy because you can key amplifiers or you can key the rig.
Yep.
Sort of either way you want.
Do they have, just a matter of interest, do they have different antenna outlets for each of the bands?
They do have the 9700 has obviously the sort of three bands, so three antenna outputs.
Okay, great.
So if you have three linear amplifiers,
Yep.
Or three like linear amplifiers and preamp things, and they're all hooked up together, when you key it, you key all of them. Which, can be solved with switches and all sorts of cool things, but the boys at the Brisbane VHF club,
Microwave Club?
not sure.
No, or the
Brisbane
VHF
VHF
group?
yeah, I think it is.
Jolly fine individuals.
They are damn fine people. Look, so George VK4AMG, who's a clever guy and he's designed lots of things.
Okay.
In fact, I've got a ref gen in my 9100, which works a treat.
There you go.
Contacted me and said, look, we've got these kits. Are you interested in trying one out? And I went, my goodness. So I built it. And look, it went together really well. The poor guys, I'll pass it over and you can put it on display.
We can put it up.
Because it's version 1 of the circuit board, there was a couple of oopses that they had, as you do when you do this stuff, like the 8-pin DIN sockets that come from the factory have a certain pin out, and then the ones you actually buy to put in the kit
are different.
Yes. So it involved a little bit of
very nice.
cutting and stuff. But look, they've put together
screened and everything.
Really, really nicely. On the underside of the board is there's which you can't take out because it's all screwed down.
No.
There's quite a few surface mount sort of bypass caps and bits and pieces.
Okay. Arduino based.
Arduino based, which came sort of pre-programmed, and look, it went together really quite well.
Okay.
Again, they had a few issues with the RCA sockets that I think they originally got are physically a little bit different to the ones that they obviously did the PCB design, and you've got to spend a little bit of time and bend the pins forward to make it fit, which must be horribly frustrating when you design something to suit the bits that you've bought today, and then you go and buy another 100 and they're like different. Great. Look, it all works together, and it worked to truth. It obviously uses the CIV input from the radio, and it grabs all the other pins off from the multi.
So that's this connector.
Yeah, the 8-pin DIN, so it just plugs into the 8-pin DIN on the 9700.
So that's like an accessory socket.
That's right. So you get voltage out of that, and you get sort of obviously the sort of push to torque. So the CIV plugs into the CIV port on the radio, and basically the Arduino reads the CIV data, so it'll tell you which band you're on. And then the Arduino sort of goes, we need to switch this one. So you've got individual outputs for 270 and 23 centimetres.
And it then indicates that on the front panel.
Yeah. And look, I'm probably only change I'm going to make is that the TX and RX LEDs are astonishingly bright.
Right, and they're the ones that flash all the time.
They don't flash all the time, but every now and again they'll do a bit of it in exchange of data. But look, it went together really well, and it worked a treat sort of straight away, and it's a pretty handy thing. So
fantastic.
If you've got a 9700 and you want to be able to switch different things, it's certainly
I love it.
Certainly a handy thing. The only sort of it's not a downside to it is that because the 9700 that socket on the back will do push to torque in and out.
Oh, okay.
With my 1296 amplifier, because the sequencer is built into the amplifier, I don't actually key the radio. I basically key the sequencer, which then goes ahead and disconnects things and then comes back to the radio, and that's how I get that to transmit. But look, it's something you can work around.
So does that mean you have to break out the push to talk on the microphone?
Yes, I did. So I've got a little grey box which I've got the 8-pin microphone in. But I've also got another RCA input that when I use WSJTX or digital mode, I use the old school DTR with an octo-coupled relay to actually key that. It sounds very convoluted, but
but it gets you what you want.
When you've got 150 watts or 120 watts at 1296, you've got to sequence stuff properly.
Well and truly.
So you can't just...
Or else the smoke gets let out
touch
of things
wood.
very quickly.
It's all good so far. So. But that's a thing, so I'd highly recommend it. But look, the guys, if you go to the Brisbane VHF group, they've got quite a few projects. I know that George is working on a GPSDO. And he's also, I think, working on a project for a 9700 direct injection locking kit as well, sort of along the similar lines as the Bodner and the VK1XX one. But,
nice.
So that'll be interesting to see. So, and they've got a few other past projects that they've done, which I think we might even look at the NEC TV transmitter boards modified for 70 centimetres, and a couple of the boys have even built they built 1296 rigs on steroids. They've got SG Labs transverters in a case with a W6 PQL amplifier in it.
So with a decent amount of power.
So you feed...
With limit power.
So you feed like 2 watts in from your 817 and bazinga. So they've really got some good stuff going.
So we'll put a link in the description. To the Brisbane VHF group, and also they have they're having their MAD or their Microwave Activity Day on the 23rd of April. So that's coming up where they all get together and play microwaves.
And they've also got a really good YouTube channel. They're starting to put a lot of their older stuff onto YouTube. So there's a bit of good bit of time to be wasted there. Watching that. It's really good content.
Can I just say YouTube is the biggest time waster on the internet? But anyway,
I thought it was just me.
No. And in fact, after these sessions, we don't broadcast it, but we do have some interesting finds from YouTube. And the one that the one that I'm playing tonight is a guy has made a Tesla coil Ghostbusters portable Tesla coil. Basically, he holds it, and it's this Tesla coil that creates scary voltages, portable. So he's even got, he earths his feet, he earths his shoes. I can only assume that he didn't earth his shoes and he tried it out and realised that he had to earth his shoes.
Yeah. That's the definition of insanity. Doing the same thing, expecting different results.
Correct. So anyway, so we'll put a link on the broadcast. Now, stick around, Richard, because one of the things that I want to go to is and what I will actually do is, we just bear with me because I'm going to scan down. You see my legs there. Now, one of the so one of the things which is here, and if I touch the screen, you'll see. You'll see if I zoom, and then focus, make it a bit more focusy. Thingy. It's doing a little doobry thing.
A little screensavery.
Yeah, okay.
Promo.
So it's doing a little promo. Now, the reason for the promo is I received in the mail during the week this little hat for Raspberry Pi. That's a Raspberry Pi 3, stock standard Raspberry Pi 3. And this little hat plugs into the GPIO port, so the 40-pin GPIO port, and you'll notice on the side here there is a LiFePo battery, so a lithium ion phosphate battery which is in the size of an 18650 battery, 18650, so standard size battery, and this is a 2 amp hour battery. So you can get theoretically 2 amps out of this for an hour. And this little board, underneath this little board, there is, in fact, what I'll do, I'll take the board off so you can actually see. There we go. So there's the 40 pin that it plugs into. This is a big inductor, but there's obviously an inverter and a little bit of intelligence in here. There's a switch and there's a micro USB port here where you can charge the battery. But what this basically is a UPS, so an uninterruptible power supply for Raspberry Pi. So
there's times when you just don't want to power it down.
Well, or it gets powered down at the most inopportune time, or whatever, or you have a power failure or whatever else. So what I've actually done to demonstrate this is, and we'll walk around here, Richard, because I just need to show you the back. Now, this is the little screen. This is the little touch screen that I used for. I'm using for the Caribou, and if I turn it round so you can see it, and I'll. There is one of these boards. Now, what I've actually done is flipped the battery over to the top side because there's actually not enough room under here for the battery when you mount the Raspberry Pi on the back of this screen. But now what I've done is I've powered this up. You can see there's a little yellow little green light here. You probably can't pick that up on the screen, but anyway, little green light to say this board is now on. And there's a red LED here saying that the Raspberry Pi is also powered up. So I've done the configure. There's a little bit of configuration software that you run on the Raspberry Pi, which is all the control. So it gives you a little command line interface that you can query the UPS. You can find out what state it's in. You can flip it in. You can flip it out. You can do all that sort of stuff. Now the key thing here is. If I unplug the Raspberry Pi, you'll notice, guess what? It is actually still, I'll cancel that, it is actually still working. What it's done is decided to go small on me. Let me go up Oh, no, that wasn't right. Let me go. Oh, here we go. Let me just close that and start it back up again. Oh, come on.
Everybody loves a touch.
Oh, everyone loves a touchscreen. I've got fat fingers, haven't I? Come on, come down, come down, come down. Expand, expand. Oh, no. Anyway,
It's still working.
you still. The thing that I'm demonstrating here is it's still working, and it is fully unplugged from the power, and it still works. Now, the 2 amp hour battery, with what it's doing is powering the screen and the Raspberry Pi 4. And so it's it's bringing up the fact that, do you want to shut this down? Because yes, it can run them for probably about half an hour, but after that it's starting to run the battery down to pretty flat. So anyway, I just wanted to demonstrate the Raspberry Pi and the LiFePo. The LiFePo UPS board, whoops, and that's the little board that I'm talking about here, and it's a crowdsourced project. And this is actually generation 3. This is the 3rd generation of the particular board. They've done lots and lots of improvements to it. There is also now a real-time clock function as part of the deal, and there we go. Now we're back. Takes a little while to scan that to move that camera, but so there's a real-time clock function built into it, so you can actually get it to switch and set it up to switch at particular times and particular. Let me just focus that. That's a bit better. That's a bit better. Bring Richard in. Here. There you go. And what we can actually do here is we can even look at this. That's pretty cool, isn't it? So the board supplies 2 amps of continuous current, which will run a Raspberry Pi 4. It'll also run that screen, which I suspect it's not probably designed to do, but there certainly isn't things that are getting terribly hot here. It's more about capacity of the battery than anything, but that's a 2 amp hour battery. So it doesn't take very long to charge through the micro USB port. But I'll put the links and everything in there. They're also designed for like IoT board and IoT applications, where power supplies may be a bit dodgy.
Will that charge from the, like you obviously had the micro USB
yes,
and the power supply, so it will charge that through that. Well and truly.
It's not only through that. That just gives you an option. And
charge it on your desk before you take it somewhere.
Correct. So, neat little idea, crowdsourced. It's out there. I'll stick a link in the broadcast and the video. So yeah. Anyway, now we've got Ron watching RF and stream. Oh my goodness. Okay, and we've got Lee, who's watching from the Royal Hobart Hospital, and I hope you're recuperating well, Lee. He had a bit of an operation today, and also a shout out to Chris Webb, who had a fairly significant operation today. So I hope you're in recovery and doing well. So yeah, shout out to Chris Webb, VK7ZBX. Now, quick reminder about the repeater. Repeater's gone to Mount Wellington. I think we're all aware of that. But the receiver, for those who don't know, receivers are not only on Mount Wellington, and there's a bit of a problem with slight descents of the receiver up on Mount Wellington because of the amount of RF up there. But to get over that, there's a receiver here at the Queen's Domain, and there's also a receiver going into Grey Mountain. So, and on cue, Andrew calls in and says, "Evening, all from Signet," which is a stone's throw from Grey Mountain.
A literal stone's throw.
Literally. So up behind the back of Cygnet is Grey Mountain. So there will be a receiver and a transmitter also at Grey Mountain. So there's and they'll be there. That's a voting receiver and a simulcast transmitter. So it'll still be 146 700 and transmit into it at 146 100. So we'll still be available, and that'll be redistributed around. Not line of sight though, Andrew just said. So okay,
no,
that's all right.
No,
that's okay. Those 2 meter waves tend to do interesting stuff. So and one of the really nice things is they are all connected via VKlink, and so what that gives you the ability to do is when you transmit, you can go to a particular website, and I'll include the links on the stream. You can go to a website and see the RSSI for each of the receivers, so you can see which receivers are actually receiving your signal better. So very interesting to actually do that when you transmit. So there you go. Now we have Magazine Central. We've both got our DUBUSes, so you got it in stereo. The El Burrito in stereo. So some of the interesting thing about this, you talk about push to talk. The very first article in here is actually a very interesting little article about a 3-channel digital transmit receive sequencer. Very neat little board.
I can't believe that there are so many iterations and versions
of
sequences. All the way through to that W6PQL one. That's a board that's about that big.
That can do everything.
That does so many things.
It's just phenomenal. So they're 3-channel sequencer from 86 India Whiskey, Goran. So that's the first article. And for those who don't know, DUBUS is a bilingual magazine, so everything's in English and German. So you get the article in English, and then you get the article in German. Now, another one, which is an interesting idea. This is Barry Chambers' G8AGN, the little weather box. Now, the weather box specifically, this is a weather station with some certain additions. Because what this gives you is, it's all Arduino based, but it uses a BME 280 environmental sensor. Now this particular sensor is an absolute environmental sensor on steroids, because it gives you pressure, temperature, relative humidity, the water content.
Wow.
And what he has programmed the Arduino to do is also gives you GL, which is the combination of the oxygen and water path loss based on what it's receiving, and also what he's termed PL, which is the total path loss, which is and CN, which is the estimated carrier to noise ratio. So if you're doing microwave type link arrangements, it gives you all of the particular environmental
so you can
characteristics.
Calculate maybe
correct
your possibility of success.
Correct. So that's a little article, and he goes into the building of it and the sensor and all the things it tells you. So that's pretty cool. Now we'll just leave that one because we'll get Mr. Moncur in about that one. So if you're listening, Rex, you can make your way into the studio. The next article that we've got, that was Murray. Now this is an interesting little article. This is by LG, who doesn't have a call sign, but a switched bandwidth LC filter. So electronically controllable Q factor. So it's got a whole lot of little filters that you can switch in, LC filters which you can switch in. Very interesting, and for SDRs, almost obligatory, so that you can actually filter the incoming and also the outgoing. So fascinating little article in there. Now, what is on the front page, which is the El Burrito.
Yeah.
Now this is very interesting because we are seriously looking at 5.7 gigs right at the moment, and this is a little project at the El Burrito, very simple FM CW transceiver for 6 centimeters or 5760 megahertz. It uses, and I'll actually put this under the close-up camera because it actually, now let's go to, yeah, there we go. It actually uses a couple of modules. This is the El Burrito front end, so this is what the designers come up with, and it uses a couple of, depending on the application that you want to use, a couple of DDSs. So these are digital frequency synthesizers. And these are from something like, I think it's 25 megs to 6 gigs.
Oh, okay.
So you dial that in. And you'll notice that these little boards have the transmit and receive at particular spacings. And guess what? On the side of here, you can bolt that on there. And then what you've got here is the screen and a little bit of control, etc., etc. So this is the circuit diagram, that very simple FM CW transceiver. So you've got your antenna, your TR switch in, you've got your LNA and your PA, your little PA, so it's got a very small power amplifier in it. You've got your mixer, you've got the 432, so down to 70 centimeters, and then you've got your FM receiver, your ESP32 control board with the little LED, the OLED display, and then you've got your DDS, which is this one here, and that all plugs together into a little FM and CW transceiver for 6 centimeters. So that's
keep us busy while we're waiting for Mr. SG Lab
to
crank up.
Well and truly. So. Now, this is close to your heart. Next article, which is part of the DL0SHF team, very smart guy, from the astrophysics department of the university, aim a narrow beam at the moon.
Which is what they do all the time.
And we're talking about here, EME communications above about 30 gigahertz needs high gain antennas to provide adequate transmission power as well as strong signals on reception. So they're talking about aiming a really narrow beam up at the tens of gigahertz at a little bit of the moon. So this is some pretty special and some pretty specky stuff.
There's quite a few that are actually doing, I don't think quite a few, there's a couple that are doing regular tests on 47 gigs. Like, that's just
pretty impressive.
It is very impressive.
Very impressive. Very impressive. That's the El Burrito. Now, we'll leave that for a sec.
Yep.
That's Mr. Moncur. 144 megahertz seamlessly phased 4x28 ohm low noise Yagi stack.
These guys in Europe, obviously they love to horizontally stack antennas.
Correct. You can see over here.
Yeah.
And the phasing harness that goes with it gives you, and so it phases it all together, so you get your
50 ohms.
Well, you get 75 ohm coax
so,
as the phasing harness. Here we go. This is the sort of arrangement that we're talking about here. All come back to a point, and all of those 200 ohms all put together give you your 50 ohms.
50 ohms, yep.
So all horizontally stacked, and for applications like EME and
well, I think they do it because obviously it gives you tons of tons of gain on the H plane without sort of making the V plane too wide.
Correct. Well. And here it is in real life. So they're all pointed. A little bit difficult to point them. But you need to think about the engineering.
They're primarily used on sort of beacons and things, I think, depending on obviously the location. But
yep. So, and I think that a little bit of around the world. The last bit of DUBUS is always a bit of a look at what's going on around the world. Anyway, that's the latest edition, which is one of 2023 of DUBUS Magazine. So what we might do, if I can get you to go and get
I'll go grab Mr. Rex.
Rex, and we'll get the author in to talk about his a couple of his articles, which are in this this edition of DUBUS Magazine. So, but if you're into VHF, UHF, and microwaves, DUBUS Magazine is certainly the magazine to have a look at. It is reasonably cheap. It is delivered quarterly. It's a quarterly magazine, so you get 4 of these. They also produce a Technics magazine, which is a whole lot of the articles in these magazines put together into a particular a booklet. It's quite a thick book, which grabs a whole bucket load of these and gives you a bit of an idea of what the microwave world in around Europe and that is doing. So, welcome, Mr. Rex.
Austin,
How you going?
good.
Yeah, I know.
Reading DUBUS.
And I just came across a couple of articles that appear to have your name on them.
Yes, VK7 is about half the magazine.
Well and truly. So this particular first one, take us through what this article is about.
Right. Well, this is an exercise I undertook last year to try and extend my existing 10 gig world record, which is across from Western Australia to Tasmania.
This is the article?
And this is the article. And if you look at the little map, can you see the map?
Hang on. Let's look at the map. Yes.
Yeah, so the black line is between Western Australia and Tasmania, which is the present 10 gig world record. Now, yes, that black line was the previous world record, which went from Portugal to Cape Verde Islands.
Okay.
And the trick about this is there's what's called the trade winds, which flow from the Sahara Desert out over that path.
Okay.
And that means very dry air and very little absorption.
Okay.
When we went to Hawaii,
Which is this line over
here, you can notice that there's water all along the path. And Hilo in Hawaii is the wettest city in the whole of the United States, with 4 metres of average rainfall a year.
Right. Okay.
And what I didn't understand, I knew that there would be about 50 to 60 dB loss through path loss with the atmospheric gases.
Okay.
Including the water vapour.
Yep.
What I didn't realise is the duct actually traps the cloud.
Ah, so you get more attenuation in the duct.
Yes, by about another 60 dB.
Yeah, okay. Righto.
And while we had enough for 160 dB of loss, we didn't have enough for 260 dB of loss.
Okay. Okay.
And that was the reason we are pretty sure why it didn't work.
Okay.
Bearing in mind, we at the Californian, one guy used.
Oh, there's a picture in here.
Yes.
There is a. Hang on. Bear with me.
Yes. This system, which actually ran 725 watts on 10 gigs, and got 500 watts to the feed.
And this is a trailer mount. And
Trailer mount.
That's a generator.
There's actually 2 big generators there that paralleled up produce enough power to run a TWT, which are generally not very efficient, to get 725 watts of RF out.
So how much power would they be putting in for 725 watts out? Probably 2 or 3 times that, at least.
I'm sure,
At
yes.
least. And that's an offset feed dish.
An offset 1.8 metre dish. Which
So here's the feed,
Yes.
and I assume that's pointed at the horizon. That'd be pretty.
Yes, there's a rifle scope there. See the rifle scope?
yes. Just here.
Yes, which has been calibrated.
Okay. And that's a big counterweight, I assume, then, is it?
Yes.
Yeah, okay.
So we had probably the best station you could imagine at that end.
Well, not truly.
Now, while I didn't have the power, I didn't even receive anything from him.
Yeah, okay.
So we were a long way short of a QSO because I was only running 50 watts.
Yep, yeah.
To the left, up to the top of the picture, you can see a 432 meg Yagi.
Yep.
Which we got 432 meg signals about 50% of the time we were on the mountain.
So that's Whisper or SSB?
Whisper.
Oh, Whisper, okay, okay.
Best of plus 15 dB on Whisper over 4,000 kilometres on 432 is not too bad.
Plus 15?
Yeah.
Oh, that's it, that is SSB.
Oh yes.
That is well and truly.
Except that the guys at the other end had all been set up just to transmit Whisper so I could receive it.
Okay.
So we didn't actually have a contact on 432.
Okay.
But what actually happens is, because of all this moisture in the duct, the refractive index, the change of refractive index is quite dramatic from above the duct to all the moisture and then below the moisture.
Okay.
And that makes the duct extremely good on VHF, where the absorption is not that important.
But not good on...
Well, the higher frequency you go, now they have completed this path all the way up to 5.6.
Okay.
But it looks like 10 gig. I mean, the absorption, the water vapor absorption increases dramatically between 5.6 and 10. So I think it's probably not possible, but you can't say never is never. So the main reason for that article is just to explain why we think it didn't work.
Well and truly. Well, that's fantastic. And then we went a bit further on here to find that there was another article in here by Mr. Moncur, which is...
on a rural scatter.
Correct.
Now, this channel, OTC, has run 3 or 4 stories on a rural scatter. And this was the first one.
Oh, okay.
It takes a while to get things into a magazine and so forth.
Yeah, okay.
But it does show that a rural scatter works extremely well on Q65 in the widest mode and the shortest period. 15C works extremely well on a rural scatter. And since writing that article, we've had some big auroral events, one of which produced over 1,200 decodes. So we think Q6515C is going to be a major breakthrough for auroral scatter.
There you go. Now, and this one, I'll just point this out. This one has a bit of an interesting couple of decodes here. It was obviously at Christmas time.
Yes. Well, I asked Jody to send some text messages so that we could show that it would still work even without all of the...
And you didn't know what he was going to send?
I had no clue what he was going to send.
Well, there you go. There you go. Well, that fulfills one of the contact...
Well, even the others, I didn't know what signal report he was going to send.
Yeah.
I did know the call signs. But
actually, -7 and -6, that's pretty good.
Oh, yes. There were some very strong signals.
And that was the first event.
That's right.
That was...
I think the strongest we've had is +7.
Okay.
Of Aurora.
Well, there you go.
On some of these later events.
So is there more to come in a future DUBUS magazine?
Probably, but for this next DUBUS magazine, all I've actually done is a short report saying, look at these URLs and you will find the OTC presentations.
Good promotion, Rex. Good promotion.
Yes.
Excellent.
So
Now, what I was going to do was, there is an article, this is OTN, which is the Radio Amateurs Old Timers Club magazine, the last one. Now, we've done a few things out of here, but one that I was going to want to focus in on is one by Paul Edwards on Operation Starfish Prime. Now, recollections of a high-altitude thermonuclear explosion, and this is by Paul Edwards, who is VK7ZAL, and I'll just read the introduction to the article. Just over 60 years ago, on the 9th of July 1962, the US Department of Defense detonated a 1.4 megaton hydrogen bomb, Starfish Prime, 400 kilometres above Johnson Island in the Pacific. The burst had spectacular and long-lasting effects, some of them unexpected. It generated auroral display and geomagnetic disturbances, disrupted HF communications and electric power utilities, and injected radioactive debris into the upper atmosphere, leading to the premature death of at least 6 Earth satellites. Whoops. So, the effects were seen as far as Hobart, where I handled the VHF telemetry, that's right, from a balloon-borne Geiger counter, which registered a high-altitude radiation burst. The article was prompted by my recollections of the event, as I recently cleared out a largely forgotten papers and reports dating from that time. So it's a fascinating article. Here's Paul. Paul. Oh bugger! There goes my mouse. Anyway, no, don't worry, Rex. You won't be able to grab it, or can you? We'll just try. Oh, thank you. I really need to put a tether on that. Here's Paul Edwards, the author here, showing unfurling the end-fed half-wave transmitting antenna prior to the balloon launch. The 80-inch long antenna hung below the styrofoam insulated 11-inch aluminium cosmic ray radio sonde.
yes, on 72 megahertz.
On 72 megahertz. Well, there you go. So the don't worry. That is, I'm not quite sure why that's slightly out of focus. The 72 megahertz radio sonde antenna.
Yeah.
That he used. The original rack mount equipment, the receiving station, the super regenerative SDRD, S/RD is at the bottom left. And the cosmic ray counters and timer top left over here, cosmic ray decade counters. And the data were read out in real time. so there you go. And a few little circuits, the 1950s vintage 72 megahertz RF Cascode preamplifier and super regenerative telemetry receiver.
What was it? 6?
It was a 6 AK5 to start with.
Oh, that's a bit different. Yeah. Oh, that's the receiver. Yeah.
6 BS8.
No, what's the transmitter? Is this a transmitter?
No. These are all receivers.
Yeah.
So the transmitter, that's the Geiger counter, that's the radio sonde transmitter. So that is a 1S4.
1S4. Don't remember that.
And the Geiger counter pulse modulating circuit, a 1Q5 GT.
Right.
So, absolutely fascinating article about Paul's recollections, and sending a Geiger counter up in a radio sonde balloon, and then receiving the VHF that came back from it. Now, I assume I'm not sure whether they recovered it, because I haven't read the article yet. Did they recover the?
I doubt it.
Because the balloon would have exploded and then it would have fallen to Earth.
Yes.
I assume.
They're pretty big balloons to cut all this gear off in those days.
Well and truly.
Yeah.
Hobart amateur Len Edwards. Now Len Edwards is the antenna, what became Moonraker antennas.
Okay.
Had also a setup at Starfish monitoring station. He accurately timed and recorded the sudden fade and subsequent changes in the 10 meg WWVH, so the Hawaii time signal. So. But anyway, I just wanted to point that out because there's a bit of a Tasmanian connection with that particular story, as well as many others. So yeah. Now I'll probably oh, hang on. We've got downside of a wireless mouse. Yes, thank you, Sean. And Andy Cowley, hello. Is 2E0REE. My goodness. Okay. Where is that, Andy? If you're still listening, where are you coming in from with that call sign? What's a 2E0 call sign? I'm not sure. Anyway, I'm sure he'll tell us. Now, we'll hold this over until next week, but the latest and greatest amateur radio magazine is in people's either email mailbox or in their physical Portsmouth, UK. Thank you, Andy.
Wow.
So there you go. On the other side of the world, will be the morning.
Yeah.
So we'll hold this over until next time. But there's a great little article in here from Jim Tregellis about a very handy. He calls it the crafty rig and amp tester, a little circuit that Jim's put together. Interesting. Earthing arrangement for your shack, as well as a great article about the International Lightship and Lighthouse Weekend, which is coming up in August, the weekend after the Remembrance Day contest. So great, as well as a whole bucket load of other things. Now, I'll just remind people, one of the things that we've been able to do for June 2023, is actually the centenary of organised amateur radio in Tasmania. So in June 1923 was when the Tasmanian division of the Wireless Institute of Australia was incorporated, and we've been able to find the meeting notices and the registration and all sorts of things. So we certainly know that it was in June 1923, and we're planning a whole lot of things. One of them is to have for June, the June edition of Amateur Radio Magazine will actually be a focus on VK7. So there'll be quite a few historical articles as well as some contemporary articles in there as well, all from VK7. We've got a Wireless Institute broadcast, Sunday broadcast, that will be brought to everybody from VK7 and be read by lots of people from Tasmania. So we've got a few activities. There is a special call sign, which is VK7 Whiskey India Alpha, so VK7WIA, that will also be active for the month of June, and there'll be lots and lots of Tasmanian operators who will all be making contacts on VK7WIA. So there's a whole lot of promotional material that's about to go out in relation to June being the VK7 centenary. So watch this space. So anyway, now just a reminder, our May presentation night is by Feo Marine. Now, what do Feo Marine do? They're a marine electronics firm. And Brendan from Feo Marine is very keen to give us a talk about subsea acoustic communication methods. So acoustic communication methods are used for all sorts of things. One of them that FIO Marine does is acoustically activated buoys. So these buoys, basically, you send it an acoustic sequence, and they sink or they float. And if they sink, well, you can leave them on the bottom, and then when you want to raise them up because they've measured, I don't know, they've measured what they have to do, or they've recorded what they have to do, you go to the somewhere near this buoy, send it the sequence that you need to as acoustic tones, and magically the buoy activates and comes to the surface. And so, pretty impressive stuff. I can think of lots of potential for Antarctic research type.
We used to use them.
Oh, okay.
Yeah. And that's in my day, which is a long time ago.
So what did they use them for, Rex? What was the sort of application?
They measure things like currents at different depths.
Okay.
Temperature, salinity.
Okay.
Probably. I think that's all.
So they'd bring them to the surface and then get the data or whatever
that's
they
right.
had
Yes,
to do.
the data was recorded on little memory sticks.
Yeah.
Things like that.
Okay.
And then you'd bring them to the surface, replace the batteries.
And then sink them back down again.
Yeah.
Okay. Well, there you go. So May's presentation is subsea acoustic communication, and some of the Brendan's going to go into some of the techniques that they actually use, the RF type techniques, which but at acoustic at audio type levels. So it should be a fascinating presentation. That's on the 3rd of May, Wednesday the 3rd of May, and we will be broadcasting it and also streaming it. So it should be a good presentation. And then of course we're into the month of June, so watch out for all sorts of things centenary for the month of June. So anyway, that's our presentation on for tonight. Thanks for watching. Hope you've got something out of it. And by all means, let people like the video. Let people know that it's about. It happens every Wednesday night. We'll get people along and hopefully get them interested in amateur radio. So there you go. So thank you, Rex.
Thank you, Justin.
Thank you. And that's our VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night 73, and we'll catch you same time next week. 73.